Before starting this video, I want to let you guys know that Coding Cleverly also has a Patreon page. So go to patreon.com/codingcleverly and you'll see that there is a Patreon page that is available, and you guys could support the channel by just joining any one of these tiers. You guys also could become my patrons. That would also motivate me to provide better and better content. So all you got to do is go to this page and show some love to Coding Cleverly. Enough with the shameless plug. Now let's go to the video. Using graphs to model complex networks is great, but graph search algorithms are another way graphs can be useful. A graph search algorithm can be used to traverse the entire graph data structure in search of a specific vertex value. There are two approaches to using a graph search to navigate a graph: DFS and BFS. DFS, or depth first search, follows every possible path to its conclusion. BFS, on the other hand, or breadth first search, expands the search from the point of origin to an ever-expanding circle of neighboring vertices. To track down what we visited, we add a list. This list will be very crucial because it prevents the search from returning to the same vertex multiple times. This is especially important for cyclical graphs, where you could otherwise end up in an infinite loop, and we've seen this in our previous videos. So you might be wondering, how does one compute the runtime of graph search algorithms? In an upper bound scenario, we would examine every vertex and edge. As a result, the big O runtime for depth first and breadth first search is O of vertices plus edges. So you have the O and you have bracket vertices plus edges. Now here's a question. What if you don't need to find a path, but you do need to find a list of all the values in a graph? What should be the solution there? Well, it turns out that in addition to path finding, depth first search is pretty adept at organizing vertices or vertex values with a clear order of visitation from beginning to end. So you could use depth first search to find a path, like instead of path finding, but you could organize and show the layout of the complete graph structure using depth first search. There are three main traversal orders that you'll come across for graph traversal: pre-order, post-order, and reverse post-order, also known as topological sort. Pre-order, in which each vertex is added to the visited list and added to the output list before getting added to the stack. So that's just one thing to remember here. In post-order, in which each vertex is added to the visited list and added to the output list after it is popped off of the stack. And then reverse post-order, which is also known as topological sort, which returns an output list that is exactly the reverse of the post-order list. So post-order and reverse post-order are just like the opposites of each other. Here I have a cool graphical representation of a graph. Take a look at this directed graph structure that I've depicted here. Let's say that we want a list of all vertex values starting with 1 in the order that they are added to the stack. Now a pre-order DFS traversal would come in handy. Now over here we'd assume that the algorithm prefers visiting things in numerical order if there is a choice. So our target value is 1, and normally you would get a target value from the program. So our target value is 1 here. So we're starting with 1. We'll go with 1. So this is the first thing that's visited. This is also going to be on top of the stack. So over here, if we have a choice, we're going to prefer visiting the minimum number. So over here we have 3 and 4. We're going to check 3. So we're going to go and visit 3. And we're also going to put it on top of the stack over here. After that, we see that there's 4 and 2. So we're going to look at the smaller number, and we're gonna visit it. So 2 is going to be over here. 2 is also going to be over here. And then we're also going to check for 5. So because it's 5 and there's no other option, so we're going to have to check 5. We'll put it on the stack as 5 over here, and the visited will go over here as well. Now the important part came, and you could see that there's nothing after this. So we'll have to pop this thing out of the stack. So we're going to have to, I'll just pop it out like this. And now we'll check 2. So 2 still has nothing with it. So we'll pop that out as well. And then we'll check 3. So 3 has something. So it has thing that was not visited, and it was 4, and it's not in the visited set. So we're gonna add that 4 over there. So just add 4 to the top of the stack here, and we're gonna add 4 here as well. Now we're gonna check for the 4. and we're gonna see, well, the 4 doesn't have anything, so we're gonna pop that out of the stack as well. And then after that we have 3, so we're looking at for 3 something, any number that is already that is not visited. So everything is visited, 4 and 2 are visited, so we're gonna remove 3. We're gonna look at 1, and if there's anything that is not visited, we'll have to check, but there's nothing, everything is visited, 3 and 4 are there, so we'll remove that. So this is how our list will appear, 1, 3, 2, 5, 4. So this is the pre-order DFS traversal. All right, so like I said, that pre-order is that kind of order in which each vertex is added to the visited list and added to the output list before getting added to the stack. So this was our pre-order traversal. Now we want to look at post-order traversal, in which each vertex is added to the visited list and added to the output list after it is popped off of the stack. So if we take a look at the post-order traversal, we'll go like this. So for the first thing, it's 1. So we're just going to look at 1. We're not going to add it to the list or anything yet. Then we're going to look at the smaller number, which is 3. Then we're going to look at something even smaller than that, which is 2. Then we're going to look at something, then we have 5. So there you go, the last number came. So it's going to go like this, 5. And then after that, it's going to go and see the 2 because it's going to be popped off as well. So 5, 2. And then we're going to look at 3. So 3 actually has something for this. So we're going to have to add 4. And then we have nothing over here, so 4. And then we have back to 3. So back to 3, and then we have the last one, which is 1. So this is our post-order traversal. This is how it's going to appear. And the reverse post-order, which is also known as the topological sort, will return an output list that is exactly the reverse of the post-order list. So this is the post-order traversal, and the exact opposite of this is 1, 3, 4, 2, and then 5. So this here is the reverse post-order, also known as the topological sort, and these are just different ways to traverse the graph. The most common was the first one, which was pre-order, and that's the default thing. And it's easy for us to just get a full overview of the graph like that. All right, so let's have a conceptual overview of how the depth first search DFS is gonna work. So let's suppose we have our target value as 1. So we're gonna go and visit 1 here, and we're also gonna put it on the stack. So this is the top of the stack. Then we'll have to look at the number that is smaller from the choice over here. We got 3 and 4. We're looking at the smaller number, and we'll put 3 on top of the stack here, and we'll put it as our visited set as well. So we have 3, and then after that we look at the smaller number from these two, and the 2 is the smaller number, so we'll put it in the visited set, and we'll also put in the DFS stack. So we'll put it up on the top over here. And now we can see that 5 is the only option, so we'll have to use 5 here as the visited, and then we'll have to put 5 here on the top of the stack as well. Since there's nothing over here on the there's nothing after the 5, so we're gonna have to pop this out. So to do this, we're gonna have to just select this number and just pop it out. And now we're gonna look at 2. So there's nothing with 2 as well, so we're gonna have to pop this out. 3 has some unvisited vertex, which is this 4 one, because this is not in the set over there. So we're just gonna have to use this now. So we're gonna use 4, and we're gonna put it over here. So 4 is gonna be over here, and 4 will be on top of the stack as well. Now we look at 4, because this is our current vertex, and there's nothing over here that's unvisited. So we're gonna have to pop this out again. So let's just pop it out. So there you go. So this is popped out, and now we look at 3. There's nothing unvisited, so we'll just pop this out. Look at 1, and there's nothing unvisited, so we'll just pop that out. Once the stack is complete from here, so it's empty, we'll have a list over here, 1, 3, 2, 5, 4. And this is a list of all of the vertices inside of this entire graph. So we have 1, 3, 2, 5, and 4. This was our DFS, depth first search. Now let's write the code for this. So here I have a class graph traverser, and it has a main method, and also I have a sample graph that I've created earlier, and it just contains some vertices, and yeah, it just has a method here that says get starting vertex, and we'll get the first vertex here from the graph. Now our job here is to write the code for a depth first traversal. Traversals are extremely useful when trying to find a specific value or path in a graph. We'll start with the depth-first traversal method for recursively traversing a directed graph. To summarize, depth-first traversals iterate down each vertex, one neighbor at a time. In this video, I'll focus on traversing the entire length of a single path and printing the data value of each vertex. Now in testgraph.java, I've created a sample graph for us to test the traversals against. This is all linked to my last video about graphs. So we created a graph here and we have this input is weighted as false and is directed as true. So there's no weight, but it's directed, meaning it has directions, right? And we have a vertex start node and we have testgraph.addVertex and we have the name. So these are the names of our vertices, and yeah, so there are all these vertices here. Now I have all of these vertices that I added, and then I created these variables to associate to them. And then after that, what we did is add edges, so connections were done. After that, we created a cycle here as well. And this is not exactly the same graph that I've made in the diagram. So what I have here in the diagram was just simple so that you could easily understand how DFS works. But here I just created a complex one so that we could test out cycles as well and other things. After that, we have this graph traverser.java. To keep things simple, I created a separate graph traverser utility class in graph traverser.java, and I'll implement the traversal iterator as a static method here. Now I've seen implementations in which they created the iterator inside of the graph class. So now let's start writing the code here in the graph traverser.java utility class. We're gonna first of all, let's just add a method that is for the depth first traversal. So we say public and we say static because it's a static method, and void, and we're gonna say depth first because we're using a static method here because this is a utility class. So depth first traversal, and here I'm just gonna pass in the vertex to start with. So one, I need the start vertex, and also I need a list of all the visited vertices for this start one. So that will be called as an array list, and I'm gonna put in the vertex type here, and we're also gonna put in the name as visited, and then we have vertices. Cool. So now we're done with this. Let's add in the things here. First, let's just print out the value of our start data. So we have a system.out.println, and we say start.getData. So you might be asking, where do I get this get data from? So I already have vertex.java included here, and I've created this in my previous video. So we have a get data method, and it just returns the string data. Now we're gonna have to iterate through this vertex, and we're gonna check its edges. So all of the edges for this start vertex. So we could use an edge edge of e. So for all the edges e in the start dot get edges. So this is also a method inside of the vertex class. So over here I'm saying for every edge inside of the start edges. So this means all of those neighbors that are connected. All right, so we have to get the neighbor vertex. So to get that, we gotta use e.get end, and this will give us a vertex. You can see that return gave us a vertex, and we can save it as a vertex neighbor, neighbor. Now one thing to note here is that this e is an edge, and the get end is from the edge class. So this is also here. So get end is going to be somewhere over here. There you go. And it returns the vertex end from there. So it's just pretty simple. This one, the end vertex. Now, right after this, I'm going to have a conditional here. And I'm going to check if my visited vertices does not contain this thing, so I'm gonna add it inside. So now we can know, and we could mark that we already visited or not. To keep track if we visited vertices or not, we're gonna add this conditional. So if we're gonna use visited vertices, and then we say dot contains, and then we have the neighbor, and I say if that contains inside of the visited vertices, because you know that the visited vertices was passed here. And I'm saying if it's not inside of the visited vertices, then we want to add it. So we'll just put a negation here. And let's also quickly add this import. So just over here and quick fix, import the array list as well on top. Okay, cool. Now over here in this, inside the conditional, I'm gonna add in the visited vertices, and I'm gonna say dot add, and I'm gonna add in the neighbor vertex here. So I'm gonna say neighbor. Since our visited vertices holds vertices, and we could easily add a vertex here. The really important recursive call here is that we're gonna do a recursive call that will go to the graph traverser again. So you're gonna call the graph traverser, which is this current class, and we're gonna call the method, which is depth first traversal. And now it's requiring us a start and visited. So the visited vertices will be the same thing, but now we're gonna go with the neighbor. So NEIGHBOR. Okay, so we're done with that, and the conditional is done, and here is the for each loop, and it's going to iterate through all of the edges for our start vertex, and it's going to go until it's done. So that's pretty much it with our depth first traversal. We could test it out in our main method. We're going to create a test graph, and we're going to say test, and what we're going to say is new test graph. Okay, so where am I creating this from? This is actually from this place. And this is just creating a test graph. Remember, like I said, it created this whenever this is a public test graph constructor. And in the constructor is just doing all of the work for us. So normally we would put this in a main method, but we're putting this in a constructor. So it's creating a ginormous kind of graph with so many vertices. So v1, v2, v11, v12, all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 vertices, and they're connected edges. And what's it going to do is it's going to show us through this. So we're just going to create it here, and we're going to pass it in. So before that, we actually need the starting vertex of our test graph as well. And we had created this handy method here, which was get starting vertex, which returns us the first vertex in our graph. So we could use test, and then we say get starting vertex, and this would just give us the starting vertex, and we could save it somewhere inside because this actually returns a vertex type. So we could say vertex, and then we say starting vertex. So we'd say starting vertex, and we'll just equal it. Okay, cool. So now that it's equal, now we could add in the visited vertices. So now let's add the visited vertices list. So array list, and I'll put the type as a vertex, and I'll call this as visited vertices. So visited vertices, and here we're gonna pass in a new array list, and here we're gonna just instantiate it, so like that, and just semicolon at the end. So we created a visited vertices array list as well, and we're gonna add in the starting vertex because it's already visited. So we're just gonna add it before all of the operations, and we'll just add in starting vertex here. Cool. Now when it's done, we're done with this initial thing. Now we can finally call our depth first traversal. So this thing, and it's really easy. It's the name of the graph traverser dot depth first traversal, and it's asking us for the start vertex. So we'll say starting vertex and the visited vertices, and this should print it out. So let's go into this place, which is right here, and command prompt it here, and let's go down and let's say Java C, and we say graph traverser dot Java, and now let's just run it. So Java graph traverser. So here we have the way how this will work. That's pretty dope. Now it's time to focus on breadth first traversal. As a reminder, the breadth first traversal iterates through the graph in layers. It goes down one layer, which comprises the start vertex's direct neighbors. Then it proceeds down to the next layer, which consists of all the vertices that are neighbors of the vertices in the previous layer. And for this example, I'll focus on traversing down one layer, and then take a similar approach as we did with the depth first traversal by keeping an array of visited vertices to prevent us from iterating through the same vertices over and over. However, we will iterate through all of the direct neighbor vertices instead of iterating down the neighbor's first edge, like we did in depth first traversal. We will also use a queue to traverse through the graph instead of recursion to explore the different ways we can implement the traverse. We will reuse the same test graph that I'll reuse the same test graph that was used in the depth first traversal implementation. All right, so what I have is a directed graph, and I'm gonna have to apply breadth first traversal. So what I'm gonna do is I'm gonna get my target value. Suppose we have it as 1 starting value, and I'm just gonna put it in the visited, and I'm also gonna put it in our BFS queue. We're gonna look at our adjacent vertices and see the smaller number. So here we have 3, and we're gonna choose that as the first one. So we're gonna say 3 as our visited, and we're also gonna put 3 here as well. Now that we've done that, we look at the other adjacent one, which is 4, and we're gonna add that in our visited set, and we're also gonna add it here in our queue. Now that we've exhausted our current vertex, since there are no more unvisited vertices, so we're gonna have to remove this 1 from our queue. So we're gonna remove this 1, and now 3 will be our new current vertex. And we'll look at the adjacent ones here. So we have 2 and 4, but 2 is smaller, so we're gonna choose 2 first. And here we have 2 in the visited and 2 in the queue. Now we also have 4, but 4 is already visited here, so we're not gonna look at that. Now that we've done this, we're gonna have to since 3 is exhausted now, we're gonna have to remove that as well. So we're gonna dequeue it, and we're gonna now look at 4. Now 4 is over here, and there's nothing that we could visit, so we're gonna have to remove this as well. So we'll remove 4, and after that we could see 2 is now our current vertex, and 2 has a neighboring vertex, which is 5. So we'll put 5 here, and it's the only neighboring vertex. So we'll just put the BFS queue over here. So now that we've exhausted 2, we'll remove it from there as well. And 5 is also nothing. So there's nothing with 5 as well. So that's completely exhausted as well. So here we have completely visited the entire graph using breadth first search: 1, 3, 4, 2, and 5. Awesome. Now let's write the code for this. So I'm going to the same file where I created my depth first search, and I'm going to add my breadth first search right after this. So this is my depth first search, and right after this I'm going to create my breadth first search. So I'm going to say public, and we're also going to make this as a static method, since this is a utility class: BREADTH FIRST and then SE search. So depth first search, breadth first search, add in the vertex start, just like that, and also the array list, which is the vertex, and this is going to be called the visited vertices, just like what we did up on the top for our depth first traversal. Now, since you saw the graphical implementation there, I used a queue, so I'm going to create a queue here as well. So queue, and I'll call it visit queue, and here we're going to equal it to new queue, so QUEUE, and we're just going to put that as well. Now you might be asking, where is the queue coming from? Well, I actually have the queue file here as well. So this is the queue.java file, and we've created queues before, but I actually modified it here a little bit. So the same exact queue that we've created in our video series, but I just modified it a little bit just to add vertex as the data now instead of a string or some kind of integer. So removing that, and now let's just go here. And over here now we created our queue. It's called our visit queue, and we're gonna have the visit queue dot enqueue, the first thing, which is the start, which was passed in as the input parameter, and that's the vertex there. Now we're adding a while loop, and this is gonna go until the visit queue is not empty. So I'll say visit queue, because this is a queue, it has this method which is empty, and I've created that one. So I'll say if it's not empty, we're gonna go inside of this visit queue and keep doing those removing queue things, and traversing and using breadth first search there. So for that, let's just get something down and actually dequeue the element in the queue. So we could say visit queue dot dequeue, and here we have a vertex that we have to dequeue, so we'll put it inside of a current variable. So let's say current. All right, So now that it's in current, we could print out the value here as well. So just say system dot out dot print ln, and then we say current dot data, and there's a get data method that was in the vertex class. So there you go, it's working there. Now that we're using a for each loop to go through each of the edges inside of this current vertex, because that's what I showed you in the graphical implementation. Now I'm just mapping all of that entire explanation down in code. So I'm saying edge for every edge of the current vertex. So it's a current dot get edges, which is returning an array list of edges. And what we could do here is that, so now we're going to get the neighboring vertex of the current vertex. To do that, we could easily get it from e.getEnd, and that returns us a vertex. That's our neighboring vertex, and we pass it in to this vertex variable, and we'll call it as neighbor. And over here, we'll apply a conditional, and we'll say if the now since I'm using a visited vertices array list over here in my input parameter that checks if something is not repeated twice. So I'm saying if it's not existing, so I'll say if visited vertices dot contains and the neighbor thing, NEIGHBOR. So I'm saying if it does not contain it, then you should add it. So I'm saying if it does not contain that neighbor vertex, then you should add it. So we'll say visited vertices dot add, and so visited vertices dot add, and then we'll add in the neighbor vertex. Perfect. And then the last thing that we could do here, because we created this visit queue, and we'll enqueue this inside of our visit queue. So we'll just say visit queue dot enqueue, which is this, and we'll put in the vertex data. So we'll put in that vertex, which is the neighbor, NEIGHBOR. So this will be inside of our visit queue, which is this queue, and it just currently had only the start. But once when you get the edge of the neighboring vertex, you also pass that inside of the visit queue. So that will be now the current vertex, and it will go until there's a dead end, and then we'll just remove from the enqueue, and then so once it's exhausted, like you see over here in this while loop, so it's just going to say until it's empty, not empty. So it's just going to keep going, and once it's exhausted, like you can see over here, DQ, so we'll just see the other vertices that are there to traverse. Now let's go down in the main method and just have everything over here set like this. So just pause the video and type along. And over here for the starting vertex, test.starting vertex, here we have a array list vertex, visited vertices, the same thing, and this is the same exact thing. So instead of depth first traversal, we're going to say breadth first traversal, and the rest is history, and compiling it and running it. Let me just label them as well. So system.out.println, or we could just have a line here, so print, and then we say DFS. I'll say BFS, run this. So here you go, the difference between the two of the traversal techniques. Here we have DFS, at the other side we have BFS. So we have over here 0, 1, 1, and something like that, and then we have 2 over here. So something's going on differently, but if you look at the total numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the total number should be 10. There's 10 over here, and there's 10 over here. And if we look at the test graph.java here we have 1. Oh yeah, so the start node 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Awesome. So that was it. That was my code for depth first traversal, and thank you so much for watching the video. Please subscribe to the channel, keep supporting Coding Cleverly, and see you soon.